All right. So this is paper 2, where you're allowed to use the GDC. And specifically, if I talk about this question is your from Unit 5, chapter Calculus. And under Calculus, it comes under kinematics. Okay. So we have given velocity function of a particle moving in a straight line with velocity v is equal to t square minus 1 bracket sine t upon 2. This is what we have for the velocity function from 0 to 2. Determine when the particle changes direction for the first time. We are looking for particle change direction for the first time. So what is the condition to find like when it is changing the direction for the first time? Your velocity should be 0. When you solve this for 0, you're going to get the particle changing its direction time for the first time. So either you can use n solver, numeric solver in your GDC, where you write 0 is equal to t square minus 1 sine t upon 2 and solve it, or you can go and use the graph. Sketch it and check the x-intercept. Check the x-intercept. T square minus 1 sin x upon 2. So when I sketch it, yeah, when I sketch it, it looks like this. This is that graph you can see. You can see this graph, and this graph have many x-intercept, and we will not go beyond t is equal to 2 because the domain is 0 to 2. So, and also it asks for the first time it's changed the direction. So the first time it becomes 0, the y becomes 0, the velocity becomes 0. So this is the first time when it becomes 0 at x is equal to 1. Next time it becomes 0 when x is equal to pi, and pi value is having 3.14 greater than 2. Third time it's become 0 when x is equal to 2 pi. Again, the 2 pi would be something 2 times 3.14, approximately coming something 7 point something more than that. So we not need to go beyond 2. This is the ending point. So first time it becomes 0 at x is equal to 1. So t is equal to 1 is my answer. Are you getting this?
Yeah.
Just sketching it and getting the answer. That is what paper 2 is. If you have at least nominal concept clear, then you can get the answers. So sketch it and get the answer. So I'll write this condition, I'll sketch it and write the value for the time. So this is the answer. I'll write t is equal to 1 second. Find the velocity when acceleration of the particle is 1.4 meter per second square. Right. So they're talking about the acceleration. How do we get the acceleration? So acceleration can be found only by differentiating the velocity function. Acceleration function is the differentiation of velocity function. Differentiation of velocity function is the acceleration function. So let's differentiate it. dv upon dt. 1 upon 2. 2 is the constant. 1 upon 2 is the constant. So just take it out. And now t square minus 1 bracket sine t. I'll use here product rule. Product rule. I hope you know the product rule.
Yeah.
Product rule. If my function is u times v, the two different function, u function and v function, and I differentiate this function, I'll write u times v dash plus u dash times v. Or you can just change the order, that's completely fine. U dash times v plus u times v dash. Let's do this. T square minus 1, differentiation of sine is cos plus t square minus 1 differentiation is t square is 2t, 1 differentiation is 0, 2t times sine t. This is what my acceleration function. Acceleration function is t square minus 1 bracket cos t plus 2t times sine t upon 2. Okay.
Yeah.
Now the question is find the times when the acceleration of the particle is 1.4 meter per second per second. Find the times. So when the acceleration becomes 1.4, you can again use the n solver where a is 1.4 and that's equal to t square minus 1 cos t plus 2t sine t over 2. Or you can sketch it. Sketch the acceleration function. Sketch the acceleration function.
mm,
Next function is 1.4. Y is equal to 1.4. See here what we get. This is that acceleration function, the red color one,
yeah,
acceleration function. And this black color straight line is y is equal to 1.4. And where it is crossing 1.4, the acceleration function, before 2, it is crossing 2 times.
mm,
One at 1.344, other at 1.884. So acceleration of particle, acceleration of particle 1.4 meter per second at 1.34 second and 1.88 second. These are the two time. Okay.
yeah,
Next question. Find the acceleration of the particle when its speed is at greatest. When the speed is at greatest. So from the graph of part A, which I erased, the graph of question A, from there you can recognize the particle speed is greatest at t is equal to 2. So you need to substitute that time t is equal to 2 in the acceleration function and get the acceleration of the particle when its speed is the greatest. So what I mean to say, the section A graph, if you have seen the section A graph that we had drawn,
mm,
uh, on that time, so I'm not going to repeat that graph. So I'm just writing a speed is greatest at t is equal to 2 seconds. So what is the acceleration at t is equal to 2 seconds? Therefore, acceleration at 2 seconds would be substituting t is equal to 2 in the acceleration functions that we got. That is t square minus 1 cos t plus 2t sin t upon 2. So a2 is 2 square minus 1 cos 2 plus 2 times 2 sin 2 upon 2. This will going to give you acceleration at t is equal to 2 seconds. Time is in radian. I mean to say that sine and cos t, t is in radian. So when you substitute, you're going to get the acceleration approximately 1.19 meter per second, meter per second per second. Yes, any doubt?
No.
All right. Come to question 7. Question number 7, section B. This question 7 is of section B of paper 2. This is from a stat where you need to find PMCC, Pearson Moment Correlation Coefficient, that is R value. The following table shows the total revenue Y in Australian dollar, obtaining daily during the first week of January 2020 by Pizzy Pizza restaurant under the number of guests X served. Calculate the Pearson Moment Correlation Coefficient. That is list 1, number of guests, list 2, revenue obtained. So I can see generally it is happening when the number of guests is higher, the revenue is also higher. It could be seen in most of the column that when the number of guests is increasing, the revenue is also increasing. You can use the stat list 1 would be number of guests. List 2 would be revenue. The R value that I'm getting on the GDC, R value that I'm getting in my GDC is 0.99057. A lot of things. So I'll write approximately three significant figure, 0.991. What would I comment? 0.991 is very close to 1. The maximum R value, the maximum R value can be 1 and the minimum can be -1. And when your R is 0.9191, it means it is very, very close to 1. It means it is strong, positive correlation between number of guests and revenue obtained, isn't it?
Yeah.
So as the number of guests increases, the revenue increases. Write down Y on X. So when you obtained all this value, you'll also find there are some other values along with R. That is A, there is B, when I need to write Y in terms of X, I'll write Y is equal to AX plus B. What is A? 10.4 X and B is negative 14.25. I'll write negative 14.3. Getting this?
Yeah.
Use the line of regression to estimate the revenue of serving 70 guests. Give your answer to the nearest AUD. So X here is the number of guests. Y is the revenue obtained. So when X is equal to 17, I'm going to say X is equal to 70, I'll substitute Y is equal to 10.4 times 70 minus 14.3. What I'm getting? 713.7 AUD. That is approximately 714 AUD. Okay. Are you getting this?
Yeah.
The daily maintenance cost for the restaurant is 300 AUD. Additionally, the cost of serving one guest is 5 AUD. Determine if restaurant expect to make profit when serving 50 guests on a particular day. We need to check whether the restaurant is, registering profit when serving 50 guests, because there is maintenance charge, there is a charge for serving a single guest, that is 5 AUD. Are you getting this?
Yeah.
So let's check whether they get this in a profit or not. So in D, what I'll write, the expected profit of the restaurant by serving 50 guests. Restaurant industry is also not very cozy. So it's not like that you just open the restaurant and obtain profit. So profit here would be what? Profit would be the revenue that you generate minus cost that you have to give, isn't it? The
Yeah.
revenue that you obtain and the cost that you have to give. So the revenue function you already have. Revenue function is 10.4 times x minus 14.3 minus cost function is 300 AUD you need to pay for the maintenance plus $5 you have to, $5 you have to pay for a single guest. Now check for the 50. 10.4 times 50 minus 14.3 minus 300 plus 5 times 50. So when you get this value, what is the value? The value is negative 44.3, negative 44.3, negative 44.3 AUD. This is the profit that you expect. So what is happening here? Do we get the profit? Negative 44.3. There is no profit register on serving 50 guests on any particular day. Are you getting this? The restaurant expect to lose 44.3 AUD by serving 50 guests, isn't it? Mhm. Yes, are you getting this?
Yeah, I'm getting this. Yeah.
Now come to number E. In number E, find the expression for the profit when the restaurant is serving X guest on a particular day. So profit function we already obtained in the D, which is
Mhm.
10.4x minus 14.3 bracket minus 5x plus 300. Open the bracket, 10.4x minus 5x minus 14.3 minus 300. So what is the profit function we are obtaining? That is 5.4x minus 314.3. This is the profit function expression. Find the expression for the profit of the restaurant when serving X guest on a particular day. So it is 5.4x minus 314.3. Next comes to next part. E part 2. Find the least number of guests required to be served to the result in a profit for a day. Least number of guests. So to make the profit, I need this expression to be greater than 0. If the value is greater than 0, the profit is greater than 0, then it would going to give me the profit function. And when you solve this inequality, you're going to get the x value, which is 5.4x should be greater than 314.3. So x should be greater than 314.3 divided by 5.4, which is obtained as x greater than something divided is going to get 58.2. X should be greater than 58.2. We are talking about the number of guests. So least number of guests to obtain profit is equal to 59 guests. At least we need to serve 59 guests to obtain profit. Are you getting this?
Yeah.
Just comes to next question. Question 8. Read the question. The cannonball is fired from the top of the tower. The rate of change of height of the cannonball above the ground is modeled by h dash t. This is from the calculus. Rate of change of height is given to us when the cannonball is fired from the top of the tower, where h is in meter, t is in the time in seconds. Since the moment the cannonball was fired, determine the time at which the cannonball reached its maximum. We need to find the maxima. We already have the differentiated function. So to obtain maximum height, we need to do h dash t equal to 0. Negative 4t plus 20 is equal to 0. So t would be negative 20 upon negative 4, comes out 5 seconds. So at t is equal to 5 seconds, the ball which fired obtained the highest height, the maximum height. Okay?
Yeah.
After 1 second, the cannonball is 26 meters above the ground. Find the expression for ht, the original height. The height of the cannonball above the